In this video, we're going to start from the destructive degradation exercise, but we're going to consider some variability in the critical level. Instead of considering a single threshold set at 34, we're going to replace it with a normal distribution centered around 34, but with a standard deviation of 0.8. So we then want to calculate what is the probability of a failure after 26 weeks. So in other words, we'll be looking at the overlapping between this normal distribution and the projection of the Weibull distribution at 26. So the first thing we do is to construct a variable threshold. So that replaces the threshold at 34. So we have here a normal distribution with a mean of 34, so it's centered around 34, and a standard deviation of 0.8. And that is done simply by creating an empty folio and forcing this distribution. Next, we move on to the destructive degradation. And we are interested in deriving the degradation after 26 weeks. We can read it directly from here, and that will be the parameter of our Weibull distribution, will be the scale parameter of our Weibull distribution, or we can derive it more precisely if we need more precise measurement. We can go onto the analysis folio, which generates this sort of Excel spreadsheet type, so we can enter a formula to extract the value, and it's exponential of b multiplied by 26 weeks to the power of the other parameter a. And that gives us the reading, so we copy that, and that is the eta. Together with the beta, we have the two parameters, and we're going to insert them here. So we've inserted in the first sheet, we've inserted the parameter of the normal distribution, the critical threshold, and now here we've inserted the projection of our degradation after 26 weeks. And so we have a Weibull distribution, we have a normal distribution, so we cannot analyze it on a Weibull folio or on a normal folio, but we have to do a live comparison. So we add live comparison, and we select the critical threshold on one, and we select the Weibull on the other, and we have the two PDF compared against the other. We can project them, we can enlarge them and zoom into the area of interest, and we have our critical degradation here. And we have our threshold centered around 34, and that's a fix. And here we have the degradation at 26 weeks approaching our threshold. And this is the projection at 26 weeks. Obviously, we can easily create projection for 25, 24, and so on to see how our probability of failure changes. Our probability of failure is this area, changes as the week advance. And that's it. Thank you very much.